Section 10.1, sample spaces and probability. In this chapter, we're talking about probability and some statistics. So to do that, we need to start by talking a little bit about vocabulary. Our objective, I just noticed a typo, objective for this lesson is to find sample spaces, find theoretical probability, and find experimental probability. First things first, we need to do a little bit of vocabulary. So what I'd like you to do is I'd like you to pause this video, turn to your book onto page 538, and read the top paragraph on that page, the very first paragraph underneath sample spaces. As you're reading, I want you to jot down the definition for a probability experiment, outcomes, event, and sample space. We'll have a discussion on the definition of those 4 words in class tomorrow. So pause the video and go and read. Okay, welcome back. Now that you know what a sample space is, let's go ahead and let's find the sample space and all the possible outcomes. So here you're spinning this spinner and you're flipping a coin. How many possible outcomes are in the sample space, and list the possible outcomes. Okay, so there's a couple different ways of doing this. One way the book shows is by doing a tree diagram. Another way is just by listing. Okay, so we're going to do kind of a tree diagram and then we'll list them. So we're going to start with the tree diagram idea. So we're going to spin the spinner and flip a coin. Okay, so first of all, I could spin the spinner and get a 1, or I could get a 2, or I could get a 3, or I could get a 4. So those are my 4 possible outcomes for spinning the spinner. Now I could, if I get a 1 and then we're flipping a coin, so after the 1 I could get a heads or I could get a tails. Okay. From the 2, after I spin a 2, I could flip the coin and get a heads or get a tails. After I spin a 3, I could get a heads or a tails, and after I spin a 4, I could get a heads or a tails. So if we look at all the different possibilities here, we'd have a 1 and a heads, a 1 and a tails, a 2 and a heads, a 2 and a tails, and so forth. So we'd have, look at this bottom of the tree, there's 8 limbs total at the bottom, so there's actually 8 possible outcomes. Okay. So it says how many possible outcomes are in the sample space? There's 8 of them. And then it says list the possible outcomes. Well, we could have a 1 and a heads, or we could have a 1 and a tails, or we could have a 2 and a heads, or a 2 and a tails, or a 3 and a heads, or a 3 and a tails, or a 4 and a heads, or a 4 and a tails. So there are the 8 possible outcomes. Okay, next, the probability of an event. The probability is the measure, it's a measure of the likelihood. Measure of the likelihood of an event. Likelihood or chance that the event will occur. It's a measure of the likelihood or chance that an event will occur. Okay, so it's a likelihood, it's the measure of the likelihood or chance that an event will occur. Okay, it's a number from 0 to 1. Okay, so we think about it's a number from 0 to 1. So let's go ahead and let's do a number line here. Here's the number 0, here's the number 1. Okay, so as far as probability goes, if the probability of the event is 0, it's impossible, meaning there is no possible way that it could happen. For example, if I rolled a 6-sided dice with the numbers 1 through 6 on them, the probability of me rolling an 8 is impossible. There isn't an 8 on them. Whereas the probability, if I had a probability of 1, it's certain. It's for sure will happen. For example, the probability of flipping a coin and getting a heads or a tails. It's certain I'm going to get a heads or a tails. Our probability we write as either a number from 0 to 1, okay, or as a percent. So here at 0.5, we could also write that as 50%. And that's equally likely to happen or not. Okay, so it could go one way or the other. Okay, so basically anything above a half we say is more likely than not. Okay, or down anything less than 50%. So certain is 1 or 100%, or here 0%. Or we could also write them as fractions. This is 1/2. So this would be 1. So then we could also have like 3/4 here and so forth. And then we say here 1/4 would be, so 3/4 we say it's pretty likely. Not for certain, because it's not 100%, but 3/4 or better, we tend to say likely, and 1/4 or better, we like to say unlikely. It's unlikely to happen. Okay, so the outcomes for a specified event that we're looking for, we tend to call a favorable outcome. So when all the outcomes are equally likely, meaning the head side of the coin is the same as the tails, there's not one more than the other, then the theoretical probability is in theory. The theoretical probability is equal to the number of favorable outcomes. What are you trying to get? Divided by the total number of outcomes. And we write that the probability of event A, we write it as a P, and in parentheses A. Okay. Okay, so P of A. Okay. All right, so a coin is flipped 4 times. What is the probability that it lands on heads exactly 3 times? Okay, so I'm trying to find the probability of exactly 3 heads. So we'll do the probability of 3 H's. Okay. First things first, we need to come up with the number of favorable outcomes. How many different ways can we get 3 heads? And the total number of outcomes. So first I need to come up with my sample space. Okay, so on this we would need to list our sample space. Okay, well I could flip the coin once. Let's do a tree diagram for this. So when I flip the first coin, a coin is flipped first, so I could get a heads or I could get a tails. Okay, could get a heads or could get a tails. Well, if I get a heads the first time, I'm flipping again and could get a heads or could get a tails. Well, I'm flipping it again, that's only once, twice, so I'm flipping it again, could get a heads or could get a tails, and one more time, heads or tails. And then this one we have a heads or tails, and then this one again we have a heads or tails, and then heads or tails. So again, how you read this, I'm kind of a little squished here. I could get a head the first time, and then a head, and then a head, and then a head, so I could get 4 heads. I could get a head, a tail, could get head, tail, head, tail, tail, and so forth. The same holds true if I had a tail the first time. Okay, so again, we need to list out our entire sample space. I didn't leave a whole lot of room here. So we want to know the possibility. Let's do the tree diagram for tails then. So tails, we could get a heads and a tails. There's my second flip. Heads and a tails, and the third heads and a tails. Oh, I'm out of room. Let's do, okay, grab a Post-it if you've got it. We're going to get a little more room on this. Heads and tails. So I could have a heads or a tails on my second flip. Here's my third flip, and then here's my fourth. Okay, heads, tails, heads, tails, heads, tails. Okay, again, I could get a tails on my very first flip, then get a heads or tails after that, heads or tails after that, and then a heads or a tails after each of these. So I'm still a little even with the Post-it, so probably should have done it just a little bit bigger. Okay, so now we want the possibility of exactly 3 heads. So first of all, how many different possibilities are there? Well, let's look at my bottom row. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8. If I do a heads first, 1, 2, 3, 4, 5, 6, 7, 8. If I do a tails first, so a total of 16 possible outcomes. So there are 16 possible outcomes total. Okay, so there's 16 possible outcomes. I want to figure out how many are favorable, meaning how many are actually 3 heads. So let's go here. We have heads, 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 heads. That's 4. We could go heads, 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 tails. There's 1. So we could go heads, 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 tails. We could go heads, heads, tails, heads. That's another one. So I'm just going to kind of do a tally. Or here, we can even list them. Let's list them. That might be better. We could go heads, 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 and then a tails. Heads, 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 and tails. We could go heads, heads, tail, heads. Okay, there's another way. Or heads, heads, tails, tails. That doesn't have 3 of them. Heads, tails, heads, heads. Heads, tails, heads, tails. That doesn't have 3 heads. Heads, tails, tails, heads. That doesn't have 3 heads. Tails, tails, tails. So those are the only 3 on that side. Now let's look over here. I could have a tails, heads, heads, heads. That's got 3. I could have a tails, heads, heads, tails. That doesn't have 3 heads. A tails, heads, tails, heads. Nope. A tails, heads, heads, tails. Tails, heads, tails, tails. Nope. Tails, tails, heads, heads. Tails, tails, heads, tails. Tails, 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 heads, or tails, 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 tails. So it looks like those are the only 4 possible ways of having 3 heads and a tail. So either the tail could be flipped last, could be second to last, could be second, or it could be first. So there are 4 favorable outcomes. Okay, because there are actually 4 ways of getting what I want. So the probability of 3 heads equals the number of favorable outcomes, in this case was 4, divided by the number of total outcomes, in this case it was 16. So 4 over 16, which simplifies to 1/4. So my probability is 1/4, or you could write it as 0.25, or you could write it as 25%. We tend to write probability as a percent. That's how we tend to like it best. Okay. Okay, so that's a probability of, after flipping a coin 4 times, the probability of it landing on heads exactly 3 times. Okay, the sum of the probabilities of all the outcomes in a sample space is 1. So if I add up all the possible outcomes, like in this case, the possibility of rolling a 1 in a head, the possibility of rolling a 1 in a tail. If I did the probability of every single one of these and added them all up, the probability is always 1, or 100%. So when you know the probability of an event, let's say in this case, the probability of 3 heads we know is 25%, you can find the probability of the complement. The complement is if it's not happening. Okay, the complement is not A, and we tend to denote it with an A with a bar above it. Bar A, not A. So here we had the probability of 3 heads was 25%. So the probability of not 3 heads, so again, a bar above it, not 3 heads then would be 75%. Because when you add them together, you have to get 1 or 100%. So the probability of a complement, the probability of complement A, is equal to 1 minus the probability of A happening itself. So we took 1 minus the 0.25 and we get 0.75 in the case. That's the probability of the complement of an event. Okay, next. Example 3. When 2 6-sided dice are rolled, there are 36 possible outcomes as shown. So they show you all 36 possible outcomes. Find the probability of each event. We want to find the probability the sum is not 6. Okay, so we could do this 2 different ways. We could find straight out the probability of not 6, or we could find the probability of 6 and then to find the probability of not 6, we want a sum of 6. The probability of a sum of 6. And then to do that, we could then to find the probability of not sum of 6, we could take 1 minus the probability of a sum of 6. Hey, that might be the easier way. So let's go and let's see. There's 36 possible outcomes. So we'll go over 36. How many of them have a sum of 6? So let's go and look at different ways. 2, 3, 4, 5, 6. This one's got a sum of 6. That's 7, 8, 7. This one's got a sum of 6. We can go ahead and circle them. 6 and 6. 5, 4, 3, 4, 5. This one's got a sum of 6, 7, 8, 9. 5. This one's got a sum of 6. 7, 8, 9, 10, 10. This one's got a sum of 6. 7, 8, 9, 10, 11. And let's see, there's no sum of 6 here. 6 plus 1 is 7. So 1, 2, 3, 4, 5 out of the 36 had a sum of 6. So I would take 1 minus 5 out of 36 would get me the sum of not 6. So that would give me 1 minus 5 over 36 is 31 over 36. as a fraction, as a decimal, it's 0.861. So that's this probability of a sum of not a sum of 6. A sum is not 6. Okay, the sum is less than or equal to 9. Okay, so we could go through and count all the ones. We could do that. The probability of a sum less than or equal to 9. So we could go through, let's take a different color, and let's mark the ones. Let's grab a highlighter. Here, we'll go green. Where the sum is less than or equal to 9. Well, let's see. There's a lot of them. 1, 2, 3, 4. So let's find where the sum is greater than 9, and then use the complement. So let's find where the sum is greater than 9. So 1 plus anything is 7. So the greatest sum is there, 7, 6, 7, 8. Greater than 9, 4, 7, 8. That's not greater than 9, that's exactly 9. There we have 8, 9, so there's 10, that's greater than 9. This one's 10, that's 11, those are both greater than 9. That one's equal to 9. So we've got 7, 8, 9, so there's 10, 11, 12. So the only ones that had a sum greater than 9 are these 1, 2, 3, 4, 5, 6. So our probability of a sum greater than 9 was 6 out of 36. So to find the sum of less than or equal, take 1 minus 6 over 36, which gives me, if you simplify, 5 over 6, which is approximately 0.83. Gosh, I'm out of room. I don't leave much room on these notes. 0.83. Geometric probabilities are really just probabilities that involve lengths, that involve geometric ideas such as length, area, so forth and so on. So those are geometric probabilities. Hey, they're used a lot, well, in geometry, or also when you're doing things with length or area, such as throwing a dart and so forth. Okay, so we're going to actually start class tomorrow with example 4. I'd like you to look at example 4 in your book. It's found on page 540. Okay. We'll start class with looking at that, answering any questions that you have. I'd like you to try to figure it out. First thing is to find the area of a circle. The area of a circle is pi r squared. You'll kind of need to know that on there. So if you look at that problem, look at how they worked out the problem, then I'll work it out and we'll see where we're at. Okay. The experimental probability. An experimental probability is based on repeated trials or an experiment. So it's based on repeated trials. For example, if I was to flip a coin, we know that you're equally likely to get heads or tails. So the probability of a heads is 50%. The probability of a tails is 50%. But if I was to actually flip them, I'm not going to get a heads the first time and a tails the next time. That very rarely happens. So based on your experiment, I could flip it 100 times. We would expect 50 of them to be heads and 50 of them to be tails, but again, it doesn't always work out that way. So the experimental is actually based on repeated trials. Okay, so here in example 5, each section of the spinner shown has the same area. So we know each of these spaces is the same size. The spinner was spun 20 times, so we did it 20 times total. The table shows the results. For which color is the experimental probability of stopping on a color the same as the theoretical? So first let's find the theoretical probability. So let's do the probability of blue. The theoretical probability of blue is 1 out of the 4. Do you agree that's going to be the same for all of them? They're all going to be 1 out of the 4 because there's 4 equal pieces. The blue is 1 out of those 4. The yellow is 1 out of those 4. So the theoretical probability for all of them, this is theoretical, will be 1 out of 4 or 25%. So now we want to check for the experimental probability. The experimental probability is going off of the experiment. We spun it 20 times. So again, we want to do the number of successes over the number of trials. So for red, the probability for red in our experimental was we got 5 red out of the 20 times we spun it. Well, 5 out of 20 is, oh wait, that simplifies to 1/4. Well, the probability of the green in my experimental would be 9 out of the 20. That's not 1/4. the blue is 3 out of 20, and the yellow would be 3 out of 20. So the only one whose experimental probability matches the theoretical probability is red. Okay. Now, I don't have any your turn problems, but I want you to come and look at example 4. Okay. Try to work through that one. We'll do a couple monitoring progress in class tomorrow. Okay. And then we'll get started on your practice. So come to class with any questions that you have. Good luck.